Right, so I'm going to go up a level and call this, I guess, Lego pig. Maybe remove the light and maybe make a new node. Go in there and maybe you'll create another pig. Right, and let's make this a VDB from polygons. You can make VDBs from particles, from polygons, or from whatever. Let's make it from polygons. Let's increase the resolution a little bit, something like this. All right, so VDB can be either a signed distance field, and that will be called a surface here, or it can be a density. So let me quickly explain the difference. So an SDF, so a distance VDB, will be a sort of a volumetric representation of a surface. So this kind of looks like a surface, so that kind of makes sense. So you have to kind of think of this as, let's say we have this pig here, and there's values. This surface has values. So everything exactly on the surface will be 0. Then outside of it will be positive. So going to be 1, 2, 3, whatever. We'll just keep extending, and it will extend up to a certain point. Like if I press W to go to wireframe mode, it will you see these boxes, and these are sort of the bands. So because VDBs are sparse, meaning they don't really contain the entire. They sort of throw away data where they don't need it. So this will be the bandwidth. So it will sort of keep increasing to like 1, 2, 3, 4, whatever, like within the bandwidth. So that will become more important later, but for now that's fine. And then on the inside, it will start becoming negative. So 0, -1, -2, whatever. So you could visualize this if you do, for example, points from volume. The pig, just create some points. And do attribute from volume. So this will extract an attribute from a volume. So we could say the volume will be surface. We could bind this to surface. Get an attribute called surface, and just let's make it a float. And let's make a viewer marker and type surface. So if I do that, I get values for these points, right? So you can see these points sort of getting more and more negative, like the further they move in. And outside of there's no point, so it doesn't really do anything there. I think there's also another node which could help visualize this, which would be, I think it's called VDB Visualize Tree. So I think that does sort of the same. So let's put that in. You see, we get these boxes. I think I can put this to, I haven't used it in a while, so we kind of need to, let's put it to points. Active voxels. I can see now I get points. And these points will have color value, I think. Let me see. Points with values. There you go. And it's called VDB float. And now you can see I get these values going from positive to negative. If I were to ramp this as a color, ramp from attribute and call it VDB underscore float, and put it from minus, I think it went from minus 0.8 to positive 0.8. So you can see that these on the outside will be white, and then they'll go back to the to black on the inside. So a little bit technical, but then you can sort of understand like what a surface VDB is. So let's talk a little bit about a density VDB. So let's make another VDB from polygons. And let's make it a VOG VDB. So set of density. And let's go in the viewport, press D, and go to our scene, or go to background and make it dark so we can see it a little bit better. So sort of similar, but this will be a density VDB, and this will just have voxels with a density value inside here. So every voxel will have a certain density value, and this whole thing is like completely filled with little boxes which have the data. So instead of just being a surface representation and then having values going inside, every single voxel here contains a density information. This is generally used for something like if you were to make a cloud, for example, you would like use this, or a pyro sim, like a smoke simulation, will have density. And if we going to use this later to manipulate stuff on the inside of our VDB, we will also be using density because we have these values on the inside. So those are the two different types. But for now, let's do something with our surface VDB, because we can do quite cool stuff with this. All right, so let's increase the resolution a little bit. And VDBs can be quite heavy, by the way. So if you are going to increase your resolution, if you make it too high, your system might crash. So this, like right now, this VDB is 5.83 megabytes. Like if I divide this by 2, it's 17 megabytes. So it's kind of increases exponentially because it's 3D voxels. Anyway, so what I could do is I can make a sphere. And let's also create a VDB from the sphere. Let's make it a polygon, increase resolution, and maybe decrease this resolution. And let's type VDB combine. Right, and you can sort of say how you want to combine these two VDBs. So let's say subtract. So I'm subtracting my sphere VDB from my big VDB. And what I can then do, for example, is convert VDB. And put it to polygons. So now we're converting it back to polygons. So you can see this is it's a sort of a volume modeling. Well, you can sort of do like volume booleans this way. If you've worked in Cinema 4D, I think since release 20, they have the volume builder, and that's essentially using this under the hood. The fact about that is that I actually made a Howdini engine version for Cinema 4D based on that exact principle a couple of years ago, which uses this as well. So it was essentially the volume builder before there was a volume builder inside of Cinema 4D. So you can see it here. So it was 4 years ago. So anyway, so you can do pretty cool stuff with this. So there's like other options you can do as well. So you have VDB smooth SDF, for example. So let's go VDB smooth SDF. So for example, this will smooth out the SDF. We can VDB reshape SDF. So that's, for example, if we put this in here, not sure if that's going to work because of the bandwidth. Okay, let's just do it over here, just to demo. So you can, for example, set this to dilate, and then it will sort of inflate our VDB, like we sort of similar to what we had with our normal thing. So now I have it as polygons, and put it to erode. So I can sort of erode my surface this way. So you can see this can give pretty cool, you can do pretty cool stuff with this. So VDB, so let's do this smooth SDF, put it in here. So now the smoothing actually makes sense. So now we made a sort of a weird little thing. So you can combine VDBs this way. So this also works with like density VDBs. So let's say I do a have this VDB, let's make it a Vogue VDB. Let's make a make our sphere. Let's grab this sphere, make this also a Vogue VDB. Let's do VDB combine. Let's just grab this one. You can see this also works. And the cool thing about this approach, this also works on density, is that you can also convert these back and forth. So I can say convert VDB. And instead of converting it to polygons, I can say VDB and I can say convert fog to SDF. So right now I created, like I changed my fog to an SDF. And right now you might probably think like, but what's the point of this? Because I mean, I can do the same operation on both of these things. So that's where we're going to talk about now. So let's do something with a volume VOP. That's why I wanted to like talk a little bit about VOPs before. So there's also something called a volume VOP. So let's copy and paste our pig again. Let's make it into a VDB. And let's type volume VOP. And let's put it down. Right, so initially nothing happens. The volume VOP is a little bit different than a regular VOP because this works on every voxel instead of every pixel. And also the thing is with volumes is that you cannot really inspect values inside of your spreadsheets because like density just counts as a primitive and it just has one and it's density. So if I add another one for color, it would be color. You cannot really inspect it easily. So that makes it a little bit more tricky to work on. But inside of here, a lot of the same techniques apply. So there's a couple of different parameters here. You can see there's still position, but you can see density is going into density. So just passing through by default, because if I remove this, I'm not sure, I thought it might even disappear. That's not, but since we now have this connection here, we could say, let's do something with that. Let's put down a turbulent noise and let's multiply. So position, and let's promote some parameters. You can see it already disappeared, but probably because of our settings. Right. Change the what's going on here. Let's see. Let's up the resolution a little bit. And let's do a different noise type, I think. I think we did something. Oh, I put density into position. That's why it's like, that's why I said before you need to sample the position, else it won't know where to put it. So I put density into position. Of course, this doesn't know where to place the noise. Anyway, so now you can, let's put it back to alligator noise. So now you can see that by multiplying my density with the noise, I get this sort of cool cloudy type of thing. And that's because this density has like density values for every voxel. Like if I were to do this on my, so copy and paste this on a surface, let's create this a surface VDB. Let's plug it in there. It doesn't work. Of course, putting it to density, but even if I say bind, so bind is importing it and type surface, and then bind export surface. Yeah, I keep making the same typo. Multiply. So this is still not really doing? Well, you see something happening, but it will still just be the representation of the surface. So it does do something, but not really what we want, right? But again, like I mentioned before, is that I can convert these VDB types back and forth. So if I type convert VDB, put this in here, and then put these two VDB, and then go from fog to SDF. Now I have an SDF based on my density, and then I can convert this to polygons, and now I have it as a polygon mesh. Now I can do other stuff. Like I can reshape SDF, for example. I can do all of these VDB operations. And keep in mind, VDBs are quite slow, so a lot of these operations might be a little bit slow. As you can see, we made quite a cool sort of thing already. So that's kind of like when you're sort of combining VDBs and like casting types back and forth, you can sort of get these really cool, things going on. So another thing we can do inside of a volume VOP. So you might ask, when we did on the points, we could add noise to our points, because this thing, even though it looks sort of cool, it's still the same shape as our pig. Let's say we want to sort of displace that. Well, we can do that. So we need to put it into our, as our density. But we cannot really add a position to this. Like we cannot say, okay, add and then add a noise to this. Like this is not gonna work. I can show you, and then, so I mean something happened, but it's not really. I mean, it's doing something, but it is not really what we want, right? So instead of doing that, what you do is you type volume sample. Right. And you say, what does it need to sample? So let's put just output 1. And then we can say primitive name. And we want to sample density because we're working on density. If I plug this now into density, you can see, well, it changed a little bit, but so it's just, oh, I need to give it a sample position as well. Sorry. So it's the same, right? But right now we gave it a sample position. So right now we do have something to add our noise to. So let's take our turbulent noise. Add a position, type add. So now we can add it to there, and you can see it already starts getting a little bit slow. Let's turn off. You can, by the way, turn off auto update going over here. Turn this to manual, so then it won't cook until I put it back to auto, or when I actually press the refresh thing. So auto update. I'm going to reduce the resolution of my VDB a little bit. Right, so now I have some control over displacement over my volume. So it's not going to be perfect, but maybe if it helps if we increase our bandwidth a little bit. No, not really in this case. So if we want to do actual proper displacement of our volume, then there's other techniques for that, but we're not going to go into that in this course. That's going to be used in the next course when we're going to talk about simulations and stuff. But for now, just keep in mind that you can add this, and then like if we convert this now to a SDF, you can see we sort of displaced our position. because like if you want to do proper, so right now we're doing the thing where we're like adding it to the position like we did as well with the VOPs. Well, like our volumes don't really have a normal. So what we want to do is like use the normal and push it in that direction. We are going to do that in the next course when we're going to talk about simulations and stuff. But again, that's not for this course. It's going to be the later course that I'm going to be making after this. So just keep that in mind. That, well, anyway, so you can see now I converted it to a surface. I'm rotating it a little bit, and then I can convert this to polygons again. And then I have a cool polygon pig. And like when this is polygons, we can do all kinds of polygon operations that we would want to do. Like I could add the mountain thing. Like so now I'm adding like a point noise. And like the noises that we have in here also work the same way that we have before. So we could add $T in this. And now you can see this can work through the volume. So now stuff can actually sort of disappear and appear. So yeah, you can go back and forth between volumes and points, and this is what I mean by just like using data and like because like I showed you, like VOPs, it works the same whether or not you're working on primitives, volumes, points, whatever. It's gonna be the same. All right, so that's the basic VDB stuff out of the way. So this is something I really wanted to cover before we head into the next video, where we will actually start making assets for our final shot. So the underwater scene with the sort of alien squid-like thing. So because we're going to use these VDBs, for example, to create procedural rocks. So I hope you can kind of already see where that's going. So in the next video, we're going to go more into VOPs, use some more sub-level stuff, but we're going to actually start learning stuff now and build towards some assets that we can use in our final scene. So see you in the next one.